All right, let's get right into it. Today, we're tackling something huge. I mean, the biggest topic there is, the fundamental forces. You know, the rules that run our entire universe. We're talking gravity, electromagnetism, the strong and weak nuclear forces, the whole shebang. But here's the thing. What if our entire picture of them is just wrong? I mean, really think about that. Are these forces truly fundamental? Or is the very idea of separate forces just a shadow of something much, much deeper and way more elegant? The framework we're exploring today, well, it challenges that core assumption right at its root. And this quote is the absolute key. The source material we're digging into offers a pretty radical perspective, and it's all built on this one powerful idea. It basically suggests that to really get a grip on the universe, we have to stop thinking about things existing in space and start thinking about how space itself can twist and knot and behave like matter. To even begin to go there, we need what you might call a radical reset of our intuition. We have to completely deconstruct our common sense view of reality, the one that separates the stage, which is space, from the actors on it, which are particles. Okay, so this slide really gets to the heart of the matter. On the left, that's how we all instinctively think about reality, right? You've got particles, these little bits of stuff, moving around inside this big empty container we call space. But look at the right. This new framework throws that whole idea out. It says there's only the container, only space. And what we call a particle, well, that's just a little piece of space itself that's gotten twisted up and is vibrating in a stable, repeating pattern. So, and this is the crucial takeaway, we need to kind of throw out the idea of particles as tiny bits of stuff. Instead, let's start thinking of them as these persistent, stable knots of pure geometry, patterns that are literally trapped in the fabric of space itself. So let's see how this builds a completely new foundation for physics. If matter is just a behavior of space, then what exactly is space doing? Well, according to this framework, all of reality is just a single, vast, vibrating field of spacetime. Everything, and I mean everything, emerges from the behavior of this one field. And this just brilliantly illustrates what matter really is in this new picture. It's not a substance, it's a structure. Imagine a tiny, stable whirlpool in the ocean of spacetime's vibration. That whirlpool isn't made of something different from the water, it is the water, just moving in a self-sustaining, knotted-up pattern. That's an electron. That's a quark. This quote from the source material absolutely nails it. A topological defect sounds complicated, but it's really just a fancy way of saying a scar or a knot in a structure that you can't just smooth out easily. So what we call a particle is just one of these geometric scars that lasts, a persistent little wrinkle in the vibrating fabric of reality. Okay. So if matter is just knotted up space-time, then where in the world did the forces come from? And this is where the model gets incredibly powerful. The forces stop being these mysterious fields or exchanged particles and instead become simple, direct consequences of geometry. Let's start with the one we all know, gravity. To understand it in this new way, we have to do another one of those mental resets. Forget the idea of gravity as some mysterious force that's pulling things together. Instead, I want you to think of it as the natural tendency of the space-time fabric to smooth itself out. So, in this picture, a massive object, one of these dense knots of space-time, is kind of like a dent in a mattress. The space around it just naturally wants to, relax. It wants to flow back in and smooth out that dent. And that inward flow, that relaxation pressure, that's what we experience as gravity. So it's not a fundamental pull, it's an emergent push. So what about electromagnetism? Where does something like electric charge come from? It's just so elegant. Charge is simply the direction of the twist in the space-time knot. That's it. Is it spinning clockwise or counterclockwise? That one property is the origin of positive and negative charge. And this slide just makes it so incredibly clear. A knot with a clockwise twist, it behaves as a positive charge. One with a counterclockwise twist, it behaves as a negative charge. It just completely transforms this abstract property we call charge into a physical geometric feature you can actually visualize. And get this explains the electromagnetic force perfectly. Two knots that have opposite twists can mesh together, kind of like gears locking into place. That's attraction. But two knots with the same twist, they're going to clash and push each other away. That's repulsion. You don't need any mysterious force-carrying particles. It's just pure geometry in action.
Okay, so what about the forces inside the atom? The strong force in this model isn't some external force at all. It's the set of internal geometric rules that hold a really complex knot, like a proton, together. Think of it as the topological glue that keeps all the intricate twists and folds from just untying themselves.
And the weak force? That's simply the process of an unstable knot falling apart. A heavy, complex geometric knot might be a bit wobbly. The weak force is just the name we give to the process of that knot unraveling and reforming into a set of lighter, more stable knots. It's what we call radioactive decay. So let's pull all of this together. What this framework really gives us is a beautifully unified picture. The four fundamental forces aren't separate, unrelated things at all. They are all just different expressions of the geometry and dynamics of a single underlying reality, the vibrating fabric of space-time. And this table, this is really the whole story at a glance. On the left, you have the standard picture, four totally separate forces doing their own thing. But on the right, you see the beautiful simplicity of the geometric view. Gravity? That's just space trying to relax. Electromagnetism? That's all about which way a knot is twisting. The strong force is the set of rules that keep a knot from untying itself. And the weak force? That's just what happens when an unstable knot finally falls apart. It's incredible. You go from four forces down to just one single underlying principle: geometry. And that leaves us with a final, really fascinating question. We've just seen how the four forces could be nothing more than the geometric behavior of space-time. If that's true, it really makes you wonder what other cosmic secrets, what other fundamental rules are still waiting to be discovered, not in new particles or exotic fields, but hidden away in the pure, complex geometry of reality's fabric itself.